We're starting on a new chapter today, chapter 5, which deals with exponents and polynomials. We'll start off with section 1, exponents. And you'll notice it's sort of quiet, even though it is Monday morning. Seems they've cut the grass already, so I'm very appreciative of that. Now, when we see something like this in algebra or arithmetic first, I guess, we see we have the factor 5 times 5 times 5 times 5. Now, is there a kind of mathematical shorthand that is used for showing something like this? And the answer is yes. And what it is we take the basic factor, which is 5, and we call that our base. And then how many times are we multiplying it by itself? And here we see we have 4. So we call 4 the exponent. So this 4 indicates that this base 5 is multiplied by itself 4 times. Now on a calculator, you often have somewhere in a key that looks like that. That's called a caret key. And you would put 5 caret 4, and that would give you the answer. Now remember, raising something to a power is an operation. They want you to do that if you can. And for this example, we have our base here of a -3. Now, if it's in parentheses, you would put it in parentheses. And this is raised to the 3rd power. Again, if you're putting this into the calculator, you would put, I would think, in parentheses, -3 caret 3. The use of the parentheses is key, as you see as we start doing some of the examples. Okay, now going on to some specific examples. And the key is, what is the base? So, we see the base here is a 2. So we're saying 2 times 2 times 2. Well, that will be 8. Now, here they're saying 3 to the 1st power. Well, every number that doesn't have an exponent by it has an unwritten 1. So this is just 3. Now here our base is -4. So it's -4 times -4 gives us a positive 16. Now here's where it gets a little tricky, because what is our base here? And the key to this is only the 4. Now if we had it in parentheses, it would include the negative. But here it doesn't include the negative. So 4 to the 2nd is going to be 16, and then we apply the negative. So many students have gotten that wrong because they didn't realize that these two are distinct. All right, for number or letter E, the base is 1/2, and that means 1 to the 4th is going to be 1, and 2 to the 4th is 2 times 2 times 2 times 2, which is 16. Now here, there's a decimal. Again, if you put that into your calculator, it's just 0.5 caret 3, and that will be 125, but you need 3 decimal places, so that's what that one is. So it's 0.5 times 0.5 times 0.5, you need 3 decimal places 5 to the third is 125. Now, for letter G, again, we're doing strategy as well. And this is the multiplication right up there in the middle. What do you do first? Well, back in chapter 1, we said we do exponents first. So this becomes a 9. And then 4 times 9 is 36. If you did it the other way, 4 times 3, that'd be 12 squared. That's 144. That would be incorrect. Yeah, this almost seems a little bit like chapter 1 as we do some of these things. So, again, they're asking us that x is going to be 5. We have to integrate that in there, and x over here is going to be a negative 3. So, what's your strategy? Well, 2, I'd put the x in parentheses, which is the 5, that we're going to raise to the third. And for this one, it's going to be 9 over, and again, I'd put the x in parentheses, raised to the second. This way, you definitely know what the base is and the sign of the base. So 5 to the third, we said was 125, times 2, that will be 250. And negative 3 to the second, that is negative 3 squared, is a positive 9. So that's going to equal 1. Going on to example 3, again, identify the base, because if the bases are the same, then we just add the exponents. So this is going to be 4 to the 7th. And if you put that into your calculator, you'd get some big number. This one, the bases are the same, so this becomes x to the 10th. Just add your exponents. Keeping in mind there's a 1 there, y to the 4th. Here is 3 plus 2 is 5, plus 7, y to the 12th. Now again, your bases are the same, you're just going to add exponents. Now an interesting thing about this, when there is a negative sign as part of your base, and it's raised to an odd power, that is like 15 or 13 or 11 or 7, your end answer will be negative. If it's raised to an even power, 2, 4, 6, 8, 10, etc., then your answer will be positive. So raising a negative to an odd number is negative. Raising it to an even number was positive. Now in letter F, this is a little bit of a, a little bit of a problem here, because what's happening? The bases are not the same. So that's as far as you can go with this. So that's why it's so important to keep an eye on what the base is. The bases must be the same in order to add exponents. So they're taking us step by step. So in example 4, we're going to multiply the 2 times a negative 3. That's going to give us a negative 6. Then x to the second times x to the 5th, we're going to add exponents, x to the 7th. All right, just a little more practice. Remember, there is a 1 in front of this, but 1 times 1 is 1, we don't write it. So here we're just adding our exponents. Keeping in mind there's a 1 there. And here there's a 1 there, so negative 1 times 3 is negative 3, a to the 8th, b to the 11th. Now, we're changing things just a little bit here. If we were to add or multiply x to the second times x to the second times x to the second, we would get x to the sixth. Now, what would be the shorthand method of showing that? Well, it would be x to the second, and how many times have we used that as a factor? Well, 3 times. Well, if this is true, what is the rule here? And we often say it would be x to the nth raised to the m is x to the n times m, or you switch those letters around. So in a case when we're raising a power to a power where there's a parenthesis, it's not just adding, we now multiply in order to get our results. So that's what we'll be doing in our next example. Now here again, keep in mind that we're raising a power to a power, so we don't add, we multiply. That will be y to the 16th, 8 to the 20th, and here it's a negative 5 to the 21st. As we look at these, it's probably a good thing to note on our s, that's to the first power. On our t, that is to the first power. On our 2, that's to the first power. A is to the first power. In a sense, that's to the first power. This is to the first power. This is to the first power. This is to the first power. Again, we don't write those. Something to keep in mind now as we multiply through. So 1 times 4, s to the 4th. T times 4, t to the 4th. Now here we're going to get 2 to the 3rd, which is 8. I could have written 2 to the 3rd, a to the 3rd. Now here this is 1/2 squared. I'm sorry, 1/3 squared is 1/9, m squared, multiplying this and the 6th. And then this one, notice now we have to the 4th power. This is a negative, so that's going to become a positive. We don't have to worry about the sign anymore. So 3 to the 4th power is 81. Remember, it's 1 times 4. A to the 12th. B to the 16th, C to the 4th. And again, we're just moving along, giving you the strategy for dealing with different configurations of your algebra, keeping in mind that this has an exponent of 1, this has an exponent of 1. Again, we don't write them. So this will be m to the 7th over n to the 7th. And this we're going to multiply. That gives us x to the 12th. Now here, this is key. This is 3 to the 1st raised to the 4th power, which is 3 to the 4th, which is 81. Y to the 20th. Now again, you're going to have lots of practice and examples. We're showing you the technique. In this one now, we're going into dividing. So x to the 3rd means x times x times x over x times x times x times x times x. Now we know anything divided by itself is 1, and remember there is a 1 up there also. But now this becomes a 1, this becomes a 1, this becomes a 1, So all we're left with now is the 1 over x squared. Now, how would we get that here? Well, notice that when we multiplied variables with exponents, we added them. So when we're dividing, we're going to subtract, the opposite of adding. Now, often we want to add or subtract the smaller number from the larger number. So here's the basic rule. And there's a 1 left up there. When we take an exponent and it crosses the division bar, the sign of the exponent changes. So this is going to become x to the 5th minus 3, and that gives us x to the 2nd. And that's what we're showing here. But let's watch something here. Suppose we did this the other way, and we brought the larger exponent up. That would then become x to the 3rd. As this goes up, it became a negative 5. So this now becomes x to the negative 2. So what is x to the negative 2? Well, we said that this and this were equivalent. So really, all that we're doing is taking this negative exponent, bringing it across the division bar, and it's changing its sign. So we're getting a little bit of background on this, which is critical. Okay, so using this, and often they say they would like to have the exponents positive. So here we're going to bring this 2 up. That becomes a negative 2 up there, x to the 3rd. Bring the 3 up, that becomes a negative 3, 4 to the 4th. This will become a negative 2 up there, so this will be negative 3 to the 3rd. Now, kind of a trick question here. Can we do anything with that? Nope, because they don't have the common base. And in fact, I think this one here should have been, yes, I'm sorry about that, that's x, there you go. So this will be, nothing happens to the 2, but the x to the 1st comes up, this becomes x to the 4th. The negative 1 comes up, and this becomes a y. I will get on to some of our negative exponents here shortly. Looking at the text, I see they wanted us to actually simplify this. So 4 to the 4th power is 256. And a negative 3 raised to the 3rd power, remember it's going to be a negative because it's an odd power that it's being raised to, so there's negative. And 3 to the 3rd is 27. Again, I don't know if I mentioned this, but I really like the way this textbook is laid out because it's taking items in such small steps. And let's start off first with a basic rule that a variable or a number to the 0 power is 1. You might say, how did you get there? Well, a to the 3rd divided by a to the 3rd, these just cancel out and you get a 1. 1 over 1 equals a to the 0, or 1. Or if we subtract that, bring that up, we get a to the 0 power. So a little background on why this is true. Okay, so anything to the 0 power is 1. So as we look at number 1 here, 3 to the 0 power That's going to be 1. Now, all of this is in a parenthesis to the 0 power. So, regardless of what's in the parenthesis, this is just going to be a 1. Even if it's negative, if it's in a parenthesis, it's 1. Now, here's where it gets a little tricky. What is the base here in letter D? Well, it's 5. Well, 5 to the 0 power is 1, but now we apply the negative sign. So without being in a parenthesis, the negative sign is separate. So this is 5 to the 0 power, which is 1, then you apply the negative. Anything in a fraction form, it's to the 0 power, is a 1. Again, a little tricky. What is to the 0 power? The x. So that's 1. 4 times 1 is 4. And they'll be challenging you for various examples as we go along. I see we have our construction folks back here. I have a little beeping in the background. Okay, so this is sort of a little variety. This we're just going to add x to the 11th. Here we're going to multiply, keeping in mind there's a 1 there. T to the 4th and 2 to the 4th is 16. And this was actually to the 2nd here. 9 to the 2nd is 81. Remember there's a 1 there, so that makes it 9 squared. Y to the 10th. We're multiplying when we raise a power to a power. Students tend to get confused on this, but again, practice and repetition is your best way for mastery. Okay, going to our last example in our section on exponents. Here they're kind of testing us to see what's cooking. So remember, this is going to be a 1, negative 1. So 4 squared is 16, minus 1 is 15. Now in here, this is going to be a 1, and this is going to be a 1. So 1 to the 3rd power is 1, and 2, well, it's 1 to the 5th power is 1, so this is going to be a 2. And over here, there's a 1 there and a 1 there, so this is going to be 2 . Now I'm going to show you something here that may make it a little easier for you. This 3 and the 6 will actually cancel out. So this will be a 1, and this will then be a 2, and that should make it a little easier to calculate. And so this will be y to the 7 times 2, y to the 14th. This is going to be 2 to the 2nd, which is 4, x to the 10th. And by the way, had you not done the canceling here, when you got a 9 and you got a 36, you could have canceled it then as well. But they do want it simplified. So as we look at this one, it's 2 to the 3rd, which will be 8, a to the 3rd, which would be a to the 9th, b to the 4th, which is b to the 12th, over, now this is a negative 8 on the bottom, a to the 9th, b to the 2nd. Now notice your negatives cancel out, but you still have a negative sign. So your answer is going to be a negative. The a to the 9ths cancel out completely, and you're left with a negative b to the 10th. Okay, there's your first section of chapter 5.